So we're looking at the pseudocode and we're refining algorithms. We've done algorithms before, so let's not get worried. So the manager of a school cafeteria wants to use a computer system to calculate how much each customer has to pay. Members of staff have to pay VAT on their purchases, but pupils do not. If the customer is a member of staff, then the program will calculate the VAT and add it to the total cost. VAT is calculated using the formula VAT equals 0.175 times the total cost. The system requires the following inputs: how many items the customer has to pay for, the price of each item in pounds, whether the customer is a pupil or a member of staff, P for pupil and S for staff. The output from the program should display the total cost of purchases, the type of customer, the amount of VAT to be paid, and the final cost. And here's a wee example. Total cost of purchase is $2.38. The type of customer is S for staff. So the VAT is worked out at 0.4242 pence. The final cost, if we add the two of them together because the member is staff, and it's £2.80. So here's the pseudocode for that. Receive number of items from integer keyboard, calculate the total cost, purchases, get a valid type of customer, set VAT total to 0.175 times total cost, calculate final cost, display purchase details. Now note here, for the main algorithm, the pseudocode that we've written are written in less formal style using these wee angle brackets that we also use in HTML. And this tells us that these 4 steps need requirement. So we need to get the total cost of purchases, valid type of customer, calculate final cost, display purchase details. So here is our refinement. Line 1 stays the same. Line 2, we change it. So we set total cost to 0. We do a for loop. For a loop from 1 to the number of items that the person orders do. Receive item price from real keyboard. Set total cost to total cost plus item price N for. Now this is a running total in a loop. In this instance, an unconditional loop, and that is a standard algorithm, running total in a loop. We then get the valid type of customer. Repeat. Receive customer type from the character keyboard because it's a P or an S. If customer type is not a P and it's not an S, then enter P or S to display. End if until customer type equals P or customer type equals S. Now this is a standard input algorithm that we've looked at, and in this instance we're testing to check that it is the correct letter entered. Notice when it's text or a character, then it's the first check is and the second check is or. But if you're using a standard input algorithm and it's an integer, the first check is or and the second check is and. Now then, line 5, calculate final cost. If customer type is P, i.e. it's a pupil, then set final cost equals total cost. We do not add the VAT. If customer type equals S, then set final cost equals total cost plus VAT total. Line 6, display purchases, and this is the easy bit. Send total cost of purchases plus, and remember the ampersand there, the fancy plus sign, means that this is concatenation. 2 strings added together is concatenation. Total cost of purchases plus total cost, type of customer plus customer type, VAT plus VAT total, final cost plus final cost to display. So here's our problem. A program is required to prompt the user to guess a randomly chosen number between 1 and 20. The input should be validated. If the guess is incorrect, the user should be told the target number is bigger or smaller. This process continues until the target number is guessed correctly. The user should then be told how many guesses they made. And here's an example of a program that's been run. I'm thinking of a whole number between 1 and 20. What is it? 83? No, that's out of the range. Must be between 1 and 20. 0 must be a number between 1 and 20. 4.9 must be a number between 1 and 20. 11. Now, my number is smaller than your guess. What is the number? 3. My number is bigger than your guess. What is the number? 7. Correct. I was thinking of 7. And they made 3 valid guesses, 11, 3, and 7. Here's our algorithm. Set chosen number to random whole number between 1 and 20. Repeat set number of guesses to number of guesses plus 1. Get valid guess from user. Display appropriate message until chosen number equals valid guess. And they set correct. I was thinking of that, and the number of guesses was. Now we have to refine this algorithm. So pause the video and see if you cannot have a bash at least try. So let's see. Set chosen number to random number, repeat, etc. And we get to line 4. Get valid guess from user. It's got to be a number between 1 and 20. Receive valid guess, receive valid guess from the keyboard. The valid guess is less than 1 or valid guess is greater than 20. Send enter a whole number between 1 and 20 to display end if until valid guess is greater than or equal to 1 and valid guess is less than or equal to 20. Now this is our standard input algorithm, and this is for an integer. Notice it's OR and then AND. You test OR and then AND. I remember it as number or number or repeat until AND. Now line 7 and 8. Line 5, we need to change line 5's. If valid guess is less than chosen number, then say my number is bigger than your guess. If valid guess is greater than chosen number, then say my number is smaller than your guess. Wasn't as bad as it looked. There we are. Greg wants a piece of software to display the tracks he's burned onto a CD, along with the duration and settings of each track. He wants to display the total time of all the tracks on the CD. The program should initially ask the user for the number of tracks to be listed. This should be validated. At least one track and no more than 20 can be burned. At least one, no more than 20. The program requires the following inputs: the number of tracks to be burned, the title of each track, the length and settings of each track. An example of required output is shown below. And there we are. We've got 3 songs and a total running time. So here is our unrefined algorithm. Set the running time to 0, get valid number of tracks. For counter 1 to number of tracks, get length and title. Set running time to running time and track length count. N4. Display track titles and track lengths. Send CD at running time plus running total to display. You have to try and refine that algorithm. Pause the video, write your answer. So, set running total, running time to 0, get number of tracks. So, for line 2, we refine it. Repeat, receive number of tracks from your keyboard, and it's got to be a number between 1 and 20. If number of tracks is less than 1 or number of tracks is greater than 20, then send please enter number of tracks between 1 and 20 to display end if until number of tracks is greater than or equal to 1 and number of tracks is less than or equal to 20. Once again, this is a standard input algorithm. Line 4, get title and length. Receive track title counter from string keyboard and receive track length counter from real keyboard. This means that the track title and the track lengths are going to be stored in arrays. Now, but they are going to be stored in arrays because there's going to be, 5 songs, 5 titles, 5 track lengths. And if we remember when we did efficiency, it's more efficient to use an array because you only have to declare one, or in this instance, 2 variables. track title and track length, a chunk of the memory is taken up, and when the processor searches for each of the track titles, it already knows where it is. It doesn't have to find unique binary address because it has already located it. So there we get a track title, the track length, and we can see in the next line, line 5, that track length has to be an array because it says track length counter. So number 7, display track titles and lengths. For counter from 1 to number of tracks, do send track title counter and track length counter to displays. So that's a cheeky wee unconditional loop, a for loop to display all the track titles and the track lengths. And we know to use a for loop here because we know how many tracks there are. And if we know how many tracks and the track lengths, then it's got to be a for loop.